Good evening, children. May I know who is there? Kavisha. Good evening, Kavisha. Paulina, after a long time. Good evening. So we are doing integration these days. Integration. If I just go through what we have discussed so far in integration. Last day we discussed one model f dash x over fx. Problem is of this form, right? To integrate f dash x over fx, we learned that it's equal to ln mod of the denominator plus c, right? Plus c. Then another thing, another model. You have for a positive constant a dx over ax square plus x square. 1 over a square plus x square to be integrated. A is some positive integer. We have seen that this is equal to 1 over a tan inverse x over a, right? Then the next part of this, if it is 1 over square root of a squared minus x squared, the integral of this equals sine inverse of x over a. Don't forget to write plus c. So these are the things basically we discussed last day. Now today we are going to continue from there. A special case model. Next thing is a model, right? So a type of problems. If you get a problem like this, and this is how you solve, right? In integration, always we learn models, right? Identify the type of the function to be integrated, then remember the method that we learned in the class, apply it and solve, right? So that's something we don't do usually, right? I don't teach usually methods or models to you, but in integration, can't help. That's what you have to do in the coming. So with integration, we stop calculus here in areas. We just then the next topic is areas and volumes. But calculus, the next topics are uh, differential equations. In that also you learn such things, models. If the equation is like this is how you solve. If the equation is like this is how you solve, right? But we don't do that here for areas. Now, this is the model to solve a problem of the form. This is the model to integrate a function 1 over a quadratic. 1 over a quadratic, ax squared plus bx plus c. This is what you have to integrate with respect to x. This is the model. Right? You are given a function. Abhita, good evening. You are given a function 1 over a quadratic, ax squared plus bx plus c. Then how to integrate this? Right, the method is this. Right, method is if you see factors of this, right? If you see factors of this, two distinct factors, that means delta is greater than 0. In the case where delta is greater than 0, so we use factors. We use factors to integrate. මට පොඩි දෙයක් කියලා දෙන්න ඕන මේක කලින්. අපි මේ කියලිමු පොඩි දෙයක් කියලා දෙන්න තියෙනවා මේකත් එක්ක partial fractions there's a quick method, right? I have to do that. We have done this if I'm not mistaken, we haven't done that under partial fractions at the very beginning. We have done only the general methods. There's a special easy quick method to find partial fractions of some functions, right? In some special case. That's what we need here. Anyway, first we write this, then I think I'll find it. Right. Method. If the denominator can be broken into two distinct factors. Make ABC A. There are several. There are three cases. This is case 1. Can be broken into three two distinct factors. Two distinct factors. In other words, if delta is greater than 0, delta is greater than 0 means you get two distinct factors. Factors delta is greater than 0, right? That is when delta is greater than 0. So this is what you do. If you see factors easily, you will factorize it. So it will be broken into something like dx over lambda x minus mu, say lambda x minus alpha, mu x minus beta. Right? Say you break it into the denominator into two distinct factors, then you can use these factors to find partial fractions. That is a method, right? Then integrate, you can break this into two parts using partial fractions. So we integrate using partial fractions, right? We integrate using partial fractions. Maybe this is a special case of finding partial fractions. Here, this one, a special case. I'll give the special method for that, a quick method. Right? A simple and quick method. Partial fractions. B. So this is one possibility, right? This is one possibility. You see factors of this, two distinct factors of this. Then you factorize and then break it into partial fractions. Partial fractions. Use partial fractions to integrate, right? Then second case is if it can be, if you have a perfect square here, it can be, it means this transformed into, factorized as a perfect square. 1 over some say alpha x plus beta squared. If you can factorize this like this, that's to a perfect square. This is the case where delta is equal to 0, right? If delta is equal to 0, you get like a perfect square here. That is when delta is equal to 0. Now you can easily integrate. The solution is you can now take it to top. You can take it to top as to the power minus 2. You take it to top as to the power minus 2, then we can easily integrate the normal method. Add 1 to this, that's to the power minus 1. So that's, and divide by minus 1, that will give minus 1 over alpha x plus beta. It's not x, it's alpha x, so you have to divide by alpha further plus a constant. So this is the answer. If this can be expressed as a perfect square, right? C. If delta is greater than 0, you will get two distinct factors in the denominator. If delta is equal to 0, it's a perfect square, right? If delta is less than 0, you can't factorize it. No factors. It will be, then if you don't see factors, the other option is complete the square. Complete the square in the denominator. Then we complete the square. Complete the square. and it will be transformed into something like, if delta is less than 0, it will be transformed into something like delta is equal to 0, you get alpha x plus beta perfect square, right? Alpha x plus beta perfect square for delta equals 0. When you complete, if you complete the square, this is what you get, right? If delta is equal to 0, this is what you get. If delta is less than 0, you will get some negative constant here. If delta is greater than 0. If delta is greater than 0, in this case, if you completed the square, you will get some negative constant here. So you can express it as difference of squares. So ultimately, you will end up with two factors. If delta is greater than 0, you get a negative number here. Then difference of squares, that will give two distinct factors. You will end up with something like this, two factors, right? But in the case where delta is less than 0, that means you can't factorize it. No factors are there. So you should end up at something like alpha x plus beta squared plus lambda squared. It has to be a positive constant here, right? If you get a positive constant here, alpha x plus beta squared plus some lambda squared, then last day we learned if the problem converts into something like this, the solution is, this is tan inverse form. So it's equal to tan inverse 1 over lambda tan inverse alpha x plus beta. මේක තමයි එදා අපිට ඉගෙන ගත්තේ. Alpha x plus beta 1 over lambda tan inverse alpha x plus beta divided by lambda. Further, because it is alpha x, you have to divide this by alpha also, right? And plus the constant. So three possible cases. When delta is greater than 0, you will see factors easily. Then you will factorize the denominator, two distinct factors. Then we complete the square. Then we find partial fractions. Then use partial fractions to integrate, right? In the case where delta is equal to 0, it will be transformed into a perfect square here. When you find factors, a perfect square, you can easily iterate. They take it to top as to the power minus 1, as to the power minus 2, rather minus 2, then add 1 and divide by that. You know how to integrate that, right? In the case where delta is less than 0, it will be transformed, or you complete the square. In this case, you complete the square. Completing the square, it will be transformed into something like this. Alpha x plus beta squared plus a constant. Then this is another standard model, something we done last day. It is the tan inverse form, right? So whatever the case, delta is less than 0 or delta is equal to 0 or delta is less than 0, we have a method to solve the problem. That means whatever this quadratic, we can integrate it. Whether delta is greater than 0, equal to 0, less than 0, for any such function, we have a method, right? හරි කොක ලියා ගන්න ළමයි. ඊට කලින් මට චුටි දෙයක් කියන්න තියෙනවා මේ. පොඩි අත්හැරදීමක් වෙලා මේ අර පහුගිය දවස්වල වීඩියෝස් කීපයක් ඩිලීට් වුණා. ඔක්කොම පන්ති වල පහුගිය සති තුනේ වීඩියෝස් ටිකක් ඩිලීට් වුණා. මේ හැබැයි වාසනාවට මේ ඔක්කොලංගේ ටික රිකවර් කරගෙන තියෙනවා ඉංග්‍රීසි මීඩියම් නේ 2021 ඉංග්‍රීසි මීඩියම් ඒවා ටික රිකවර් කරගත්තා. සිතුම්මියා ළඟ තිබුණා. ඒකෙන් ඒ ටික මට දැන් ආයේ ලැබිලා තියෙනවා. මම ඒක අද රැට අප්ලෝඩ් කරන්නම්. හෙට පාන්දර වගේ අප්ලෝඩ් කරන්නම් නයිට් ටයිම් ඩේටා වලින්. හෙට ඉඳගෙන ඔයගොල්ලන්ට මේ දැන් අද බැලුවොත් ඊයේ හවස මගේ අතින් ඔයාලට විරුනේ. අද බැලුවොත් ඔයගොල්ලන්ට මේ පහුගිය සති තුනේ වීඩියෝස් නෑම හොයාගන්න. මම හෙට උදේ වෙනකොට ඒ ටික මේ අප්ලෝඩ් කරන්නම්. එතකොට හෙට ඉඳගෙන ඔයගොල්ලෝගේ ප්‍රශ්නයක් නෑ 21 ඉංග්‍රීසි මීඩියම් වීඩියෝස් ටික මම හිතන්නේ ඔක්කොම ටික තියෙනවා. සිතුම් යට ස්තුතිවන්ත වෙන්න තියෙනවා. තාම 2022 ඒවා මට එකයි ලැබුණේ. 21 සිංහල මීඩියම් ටික හරියට ලැබුණේ නැහැ. ඒවත් මම ආයෙ කරන්න ඕනේ. ඔයගොල්ලන්ට ප්‍රශ්නයක් නැහැ. සිතුම් ළඟ තියෙන නිසා ඒ ටික මම හෙට දානවා. හරි. ඔයගොල්ලන්ට හෙට ඉඳගෙන බලන්න පුළුවන්. පෞගේ දැන් බැලුවොත් නැහැ. හෙට ඉඳන් බලන්න පුළුවන් වෙයි. මේ මම කරච්ච වීඩියෝස් ටික. රයිට්. ඔය ටික ලියා ගන්න. මෙතන පොඩි ප්‍රශ්නයක් තියෙනවා. We have some easy method of finding partial fractions of a function like this. I'll give that before starting examples for that. For this, right? ඉස්සෙල්ලා මේක ලියා ගන්නකො. The solution the solution. Solution is better we write like that. The solution is this. Okay. Now, before going to examples of this, we will see the quick method of finding partial fractions of this. Right. The quick method of finding partial fractions of a function like this. 1 over, right? Just what is special about this is it's 1 over 2 linear factors. Right. What is this? Within seconds, 1 minute, you can find partial fractions of a function like this using this quick method. Right? We have done partial fractions earlier, but I haven't given this method. We didn't need that at that time. So method is this 1 over alpha x minus lambda beta x minus mu. Hari kalpana karna moment. Our method is the denominator of this we write unchanged, the same, right? We just write in the denominator the same. Denominator we wrote without any change, and the same pair of factors we write again in the numerator. The same pair of factors we wrote in the numerator, but now we are writing this equals this. But at first sight you see that they are not equal. We have to make them equal, right? When you are trying to make the two numerators equal, the first thing we do is, right, you get rid of x terms. X in the numerator. We first get rid of x. To get rid of x, it's easy. To get rid of x terms here, you can multiply this by beta, this by alpha, and subtract. Right? Multiply this factor by beta, this factor by alpha, subtract. So you see now x terms disappear. So you don't have to bother about x terms, but still they are not equal because a constant is here. this constant minus beta lambda plus alpha beta. Here, alpha beta minus beta lambda is still there in the numerator, a constant. Now to make them equal, we need 1 in the numerator. To make them equal, we just divide by that, right? You just divide by that. 1 over whatever the constant you get in the numerator, you divide by that. So that will be that will be mu. We have to divide by alpha mu minus beta lambda. Alpha mu minus beta lambda. Now two sides are the same, right? Now two sides are the same. Next, what we do is to get partial fractions. To get partial fractions, we divide them separately. We take this part separately and close this. Take this part separately. So we separate them, right? Divide separately. When you take this part along, so alpha x minus lambda will get cancelled. This will get cancelled. You get beta over beta x minus mu. You get beta over, dividing separately. This will give beta over beta x minus mu, right? Now you take this part along. Then beta x minus mu will get cancelled. You get alpha over alpha x minus lambda minus alpha over alpha x minus lambda. So these are the partial fractions. Within 1 minute you can do this. I'll show you an example. One or two examples. Find partial fractions. Number 1, so you have like an easy question. X minus 3 x plus 2. බලන්න මේක කොච්චර ඉක්මනින් ප්ලේසින් කරන්න පුළුවන්ද කියලා. Answer 1 over x minus 3 x plus 2. The denominator we write the same, right? Denominator is unchanged, so you write these two in the denominator. I write x plus 2 first, x plus 2 and x minus 3, right? Then write them, take them to the numerator again, right? Write them again in the numerator. X plus 2 and x minus 3. You write them again in the numerator such that the x term disappears. You want to get rid of x. Here it's very easy to get rid of x. You just subtract. X term will get cancelled. Now no x in the numerator, but it's just 1 on left. It has to be 1 here also. Here not 1, you have plus 3 plus 2. You have a 5 here in the numerator, like this. Then to make them equal, to make them 1 here, you just divide by 5. You divide by 5. Now the two sides are equal. Okay, two sides are equal. Now the only thing you have to do is to separate them. Then divide separately. 105 is waiting there outside. You take this part along. X plus 2 will get cancelled. You get 1 over x minus 3. For this particular example, 1 over x minus 3 Then take this separately. Minus x minus 3 will get cancelled. It is 1 over x plus 2. 1 over x plus 2. Right? Minus 1 over x plus 2. මේක විනාඩියෙන් කරන්න පුළුවන් වැඩක්. හරිද? ඔය කරපු මෙතඩ් එක තේරුණාද ළමයි? මම තව පොඩි ගානක් දෙන්න ඔයගොල්ලෝ නවතන්න. For the moment, is it clear? කවුද ඉන්න අය? ඔලීනා ඉන්නවා, අවිෂා ඉන්නවා, අභීත, සචින්. මොකද කියන්නේ? And somebody else. Is it clear? Paulina says yes. අනිත් අයට අවුලක් නැද්ද? Right. So if so, I'll give another question. You take this down. I'll give another one to find partial fractions. Then you find. Take it down and then do this. Example 2. Hari. Then we can go to examples of our method, right? Okay. You like the same pair on top? Now we have to make the numerators equal. First thing is to get rid of x. To get rid of x, I'll multiply this by 3, this by 2. Then subtract. To get rid of x, this by 3, this by 2, and subtract. But still, we got rid of x in the numerator, but still the two sides are not equal. We have a constant 15 plus 4. There's a 19 on in the numerator. To balance it, we can divide by 19. Now two sides are equal, then divide separately. Divide separately, you get 1 over 19, 3 over 2x plus will get cancelled, 3 over 3x minus 2 minus 2 over the 3x minus 2 will get cancelled, 2x plus 5. Is the answer. So it's very quick, right? You don't have to solve the equation, so equate coefficients to find the constants. You get them within 1 minute. Right. Now we can go to the examples of our method, right? Examples for our topic. Back to our topic, right? Examples integrate. And the other number 1 over, say, you have x squared minus 4x plus 3. Then 1 over x squared minus 4x plus 4. 3, 1 over x squared plus 2x plus 3. Number 4, 1 over 2x squared minus 6 minus 3. 5, 1 over 4x squared minus 12x plus 9. Part 6, 1 over 2x squared plus 3x plus 4. ඔය ටික ලියා ගන්නකො අපි එකින් එක කරගෙන යමු. ඔයගොල්ලෝ කරගෙන යනවාද? පළවෙනි එක කරලා පෙන්නන්න ඕනද? කරගෙන යන්න පුළුවන් මම methods දීලානේ තියෙන්නේ නේද? ඕනේ ඉතින් පළවෙනි එක මාත් එක්ක කරමු. We have like 3 cases, right? If you see factors, you just write down factors in the denominator. Write down factors. If you see factors, if you don't see factors, complete the squares. That's simple. Answer number 1. X squared minus 4x plus 3. This you can easily see factors. This is x minus 3 and x minus 1. Right? Two distinct factors. So we will find partial fractions. Use the easy method, quick method. Partial fractions. Use the quick method. Equals minus 3, x minus 1. I write x minus 1 first. Then x minus 3. To get rid of x, I just subtract. To get rid of x, just subtract. X will get cancelled. But still they are not equal. We have a 3 minus 1. The 2 here in the numerator to balance. Divide by that. Now separate. Half 1 over x minus 3 minus 1 over x minus 1. So these are the partial fractions. So this function, what is given to integrate, is equal to this. So instead of integrating this given function, we will integrate this side. Very simple, right? Now, integral of this x squared minus 4x plus 3 is equal to integral of this. So I can take half out, then integrate them We can integrate that separately. Dx over x minus 3 minus dx over x minus 1, right? I'm integrating half 1 over x minus 3, 1 over x minus 3, it is ln form, ln mod of x minus 3 minus again 1 over x minus 1, it is again ln form. ඒක මතක තියෙන්න ඕන මුලදී ඉගෙන ගත්ත දේවල්. ඔයාලා මතක කරන අයට ඉන්ටිග්‍රේෂන් කරන්න අමාරුයි. හරි? So it's ln mod x minus 1. One more step, you can simplify this a little. It's log minus log. Log minus log is equal to division. So you can finally plus c. Don't forget to write plus c. Finally, simplifying a bit, it's half ln log minus log is the division mod of x minus 3 over x minus 1 plus c. This is the answer. We use partial fractions. This is a question for case 1. Example for case 1. Right? හරි ඔන්න මම එකක් කරලා පෙන්නනවා. දැන් වෙලාව දෙනවා. කරගෙන යන්න ඉතින් ටික. ඉක්මනින් කරගෙන යන්න. I'll write answer. Take one by one. Then check, right? I don't need to explain. You just do it. This is the answer for number 2. You can check the answer for example 2. Here, no factors, it's delta less than 0 case. Delta is less than 0, you don't see factors. Then complete the square. X plus 1 squared plus 2. So it's tan inverse. 1 over root 2. Last day we learned tan inverse x plus 1 over root 2. Kira-kira na? See number 4. This is something you can easily see factors. You can write -3 and +1. Then find partial fractions. Partial fractions. Like the same here. Get rid of x, multiply this by 2 and subtract. Then x disappears, 3 plus 2, 5, we have to divide by 5. And taking into two parts. Partial fractions are 2 over 2x minus 3 minus 1 over x plus 1. These are the partial fractions. Now bring them into the question. Integral of 1 over 2x squared minus 6 minus 3 is equal to 1 over 5 integral of 2 over 2x minus 3 dx. Or you can take 2 out if you want, or if not, you can keep it in minus 1 over x plus 1. So x equal to 105 is out. Here the derivative is on top. 2x minus 3. Derivative is 2. It's on top. Again ln mod of 2x minus 3 minus ln mod of x plus 1. So log minus log, you can divide it, express it as a division. Ln mod of 2x minus 3 divided by x plus 1 plus c. This is here also, here to write plus c. This is the answer. You can check the answer for part 4. බලාගත්තද? අඩුපාඩු තියෙනවා නම් හදාගන්න. So I can go to the next. හරි මේවා අමාරු නෑ ළමයි. This methods part 5. This is something of which you can easily see factors. It's a perfect square. Dx over it's 2x minus 3 perfect square. So you can take it to top. 2x minus 3 to the power minus 2 dx. Then integrate. Add 1 minus 1. So that's this is 1 over 2x minus 3 divided by minus 1, and further it's not x, it's 2x, so you have to divide by 2. 2 finally plus c. This is the answer. That's part 5. Answer for part 5. Here in this, we don't see factors. It's delta is less than 0 case. No factors of this. Delta is less than 0. So you have to complete the square and see. To complete the square, it's 2x squared. Okay, you have to take 2 out. You have to take 2 out. It will come out as half dx over x squared plus 3 over 2x plus 2. Now completing the square, you get half dx, completing the square of this, x plus 3 over 4 squared. Then you get minus 9 over 16 plus 2. Minus 9 over 16 plus 2, that will be 32 minus 9 plus 23 over 16. So this is what you get completing the square in the denominator. Now it looks the tan inverse form. So straight away the answer, half, this is taken as a square, so 1 over a, that's 4 over square root of 23. Tan inverse, instead of x you have x plus 3 over 4 divided by a. This is a. This is a square, right? A is divided by a. That's 4 over square root of 23. Square root of 23. So we can simplify it a bit. Here you get 2 cancel, 2 over root of 23, tan inverse. You can take the common denominator here, that will be 4x plus 3. Then 4 will get cancelled. So you get only 4x plus 3 divided by square root of 23. Finally, plus c. Here also we have to write plus c. This is the answer. You can check the answer for the last part also. So I think that method, that method of that model type of problems, I think it's clear to you now, right? Whatever the quadratic in the denominator, Now we know how to integrate. So now the time to go to the next. There's another module somewhat similar to this. So shall we go to the next? Right, we go to the next module. Here, to solve problems of the form earlier we solved integral 1 over ax squared 1 over x squared plus bx plus c quadratic to integrate. This is what we just discussed. Now the difference is in this model it is ax squared plus bx plus c with the square root. So that's the difference. 1 over square root of ax squared plus bx plus c. How to integrate a function like this, right? Okay. Before going to the method of this directly, I'll give you some other questions. Exercise. You have to do this before we come to the discussion of this. Exercise 2 questions. Number 1, if y equals sine inverse x plus a over b for some constant a and b, show that dy by dx takes the form 1 over dy by dx of the derivative of this function is 1 over square root of b squared minus x plus a squared. That's question number 1. There's another. Number 2, if y equals මේ දෙකම මම මේ දීලා තියෙනවා differentiation පාඩමේ. මේ integration වලට ඕන කරන ඔක්කොම දේවල් මම differentiation පාඩමේ වෙන වෙනම උගන්වලා තියෙනවා. Now just reminding, revising and using them in integration. Y equals ln mod of x plus some constant a plus square root of x plus a squared plus or minus some constant b squared here. Show that dy by dx is equal to 1 over square root of this thing, right? Square root of x plus a squared plus or minus, no matter whether it is plus or minus b squared. Okay. Now විනාඩි කිහිපයක් දෙන්න try කරන්න. මේ ගණන් දෙක කොහොමද කියලා තියෙනවා for differentiation earlier. If first do this, then we can go to our topic. Sin inverse, the derivative is 1 over square root of 1 minus whatever you have here and square of that. Square of whatever you have here further into the derivative of the inner function, that's chain rule. Differentiating the inner function, you get just 1 over b. Take 1 over b out, the constant. Differentiating this, you get 1. So it's 1 over b only. Then simplified with b square. Take the common denominator, it will be promoted top as b, coming out of the square root as b in the root of b squared minus x plus a squared into 1 over b. So b get cancelled and you get only 1 over root of b squared minus x plus a squared. So that's the answer. The answer for the first, you can check the answer. Then the second. Y equals ln mod of x plus a plus square root of x plus a squared plus or minus b squared mod of that. Differentiating dy by dx equals, it is ln. First differentiate the outer function ln, that will be 1 over whatever you have inside x plus a plus square root of this thing x plus a squared plus or minus b squared into integrated differentiated ln, the outer function, into the derivative of the inner function, chain rule. Integrating the inner function, we get like x differentiating 1 plus a gives 0, then differentiate this. Here the outer function is square root, that is to the power half. This square root is to the power half. Differentiating that, it is half, this to the power minus half. Power minus half means 1 over square root of x plus a squared plus or minus b squared. Further into the derivative of inner function. Further inner function is this x plus a squared. So x square, differentiating, you get 2 times x plus a plus this constant, of course, 0. 2 get cancelled. The next step, we can simplify this part, taking the common denominator. Is 1 over x plus a plus square root of x plus a squared plus or minus b squared into this part. We take the common denominator, square root of what is it? Into the square root of square root of x plus a squared plus or minus b squared. So when you take the common denominator here, this part will appear here. 1 will be multiplied by this denominator. So it's square root of x plus a squared plus or minus b squared plus, further you have x plus a and this is what you get simplifying this part, simplifying that part, right? Now if you look at this carefully, if you look at this carefully, these are the same, so they do get cancelled. These two get cancelled, leaving only this equals 1 over square root of x plus a squared plus or minus b squared. So that's the answer. Karan, where is it? Now, why did I give this? Some differentiation sum, and we are doing integration or differentiation. Is it by mistake? No, not by mistake. Uh, this time not a mistake. Uh, this is what we need. This is what we get here. You differentiate this function, sin inverse x plus a over b, and this is the result. You differentiate this, you get this. So conversely, we can say by this first, we can say if you integrate this function, then the result has to be that sin inverse x plus a over b. Similarly, you differentiate this function ln mod of x plus a something, this function, you get this. This is what you get, 1 over square root of x plus a square plus or minus b square. So conversely, you integrate this, you should get this. You should get this. Okay, that is the use of what we have done here. So let's write it formally. By above 1 and 2, 1 and 2, we get these following results. We get that from 1 we get integral of 1 over square root of b squared minus x plus a squared, ab are some constants, is equal to the sin inverse thing. Sin inverse x plus a over b plus the constant c. Okay. Then from this, the second we get, and also we get integral of this thing 1 over square root of x plus a squared plus or minus b squared is equal to this ln thing, is equal to ln mod of x plus a plus square root of square root of x plus a squared plus or minus b squared equals ln mod of x plus a plus x plus a plus square root of x plus a squared plus or minus b squared, and the mod of that. Plus c. That's the use of these two differentiation problems. Okay, liya ka na naman? Then we can go to our topic. Like two important results. This and this. I will use them. I wrote them again. This is what we got. I wrote them again. So we get these two results by about two problems. Okay, now back to our problem. Now, our topic is to solve. Our topic is to solve a problem of this form 1 over ax square plus bx plus c is to be integrated, right? To integrate a function like this, the question is earlier without square root, 1 over just the quadratic, here square root of a quadratic, right? Without the square root, it is just a quadratic. We said if you see factors, then write down factors, then you can find partial fractions or take it off, right? But in this with square root here, even though you see factors here within the square root, no point of writing factors within the square root. Even though you can see you can write down factors, so you can proceed from there. No use of that. So we don't, even though you see factors, we are not going to write this. We are not going to use this, right? Here it's a different thing, right? Whatever the given function, right, with square root here, you just complete the square. So that's our method, right? To solve this, the first thing is we complete the square. Complete the square in the denominator. We complete the square in the denominator, right? So doing so, there are two possible outcomes, right? Then, so what are the possibilities and upon what it's determined? Possibilities are this coefficient. The final result is determined by the coefficient of x square, right? If this coefficient of x square this a is positive, if this a is positive, right, completing the square, then it will give you, it will transform into something like this. You complete the square, if a is positive, it will give something like this, and we have the solution, right? If a is positive, it will be transformed into this, and this is the solution. If this a is negative, it will be transformed into something like this, and then this is the solution. So if a is positive or negative, no matter whether it is positive or negative, we have a solution. That means we can solve any such problem, right? Then two cases. If a is positive, it will be transformed into something like a is positive, something like this. Integral dx root of x plus a squared plus or minus b squared. Of course, there can be some lambda here. I'll just write some constant here. Okay, that's the square root of a, right? So it's not a problem. It is this. So the solution is this. You can take that out from lambda. The solution is By this, the solution is ln mod of x plus a squared, ln mod of x plus a squared, sorry, ln mod of x plus a plus square plus square root of x plus a squared plus or minus b squared plus c, right? If a is positive, if a is positive, we have a solution. Even though a is negative, we have a solution, right? If a is negative, it will be transformed into something like this, dx over, there can be some constant outside, dx over root of b squared minus x plus a squared. So the solution is sin inverse x plus a over b. Solution is sin in lambda can be outside, there can be some lambda outside, lambda times sin inverse, it is from this x plus a over b plus the constant, right? So this is a method of solving a problem of this form. Complete the square in the, in the denominator within the square root. Then if a is positive, we have some solution. If a is negative, we have a solution for that also. So whatever the problem, we can solve, right? Okay, ලියාගන්න අපි examples බලමු. ළමයි ලබන සතියේ අපි මේ පාඩම කරනකොට partial fractions ඕනේ වෙනවා. අපි ගොඩක් ඉස්සර ඉගෙනගෙන තියෙනවා partial fractions. පොඩ්ඩක් බලලා මතක් කරගෙන තියාගන්න partial fractions ලබන සතියේ ඕනේ වෙනවා. බලලා තියාගන්න එක ගොඩක් හොඳ වෙයි. So I can write down examples here. I like them. I like questions here. You can try them. So I don't think that I have to show, do and show any of them. You just try. වෙලා දෙන්න කරගෙන යන්න. ඊට පස්සේ මම හදුවා මොකලුන්ට හරි වැරදි බලන්න පුළුවන්. You can just follow the instructions. කරගෙන යන්න බලන්න. Complete the square. You get x plus 2 squared minus 4 plus 3, that's plus 3. It's in this form. First one is of this form. So the answer, whether you get a plus constant or negative minus constant, no problem. This can be applied. So it is ln form. Ln mod of x plus 2. But here you write just x plus 2 plus square root of this whole thing. This whole thing. Plus square root of x plus 2 squared plus 3. And don't forget to write plus 3. That's the answer. Very easy. Part 2 dx over square root of 5 minus 3x minus x squared. So with minus x square here, you can't complete the square. To complete the square, the coefficient of x square has to be 1 plus 1. So we have to take minus 1 out. But can you take minus 1 out of the square root? Taking minus 1 out of the square root? So that's something you can't do. It's not real. So minus 1 you have to take inside the square root, within the square root. Okay? First step is to take the minus 1 within the square root. So 5 minus, I'll take it here, x square plus 3x. Now we have a chance of completing the square. That will give x plus like 5 minus x plus 3 over 2 squared minus 9 over 4, which is square root. Simplified, we get like simplifying, you get is equal to integral over square root of, we have 5 plus 9 over 4. That will be 29. 29 minus x plus 3 over 2 squared. Now it is sin inverse form. Answer is sin inverse x plus a, that's x plus 3 over 2 divided by b. So b squared is 29. It has to be square root of 29. Square root of 29 and plus c. Okay. You can check your answers for part 1 and 2. Then 2904 isn't 2904. Then this has to be 29/2. So it simplifies. Sin inverse, take the common denominator 2x plus 3 divided by root of 29 plus c. It simplifies to this. හරි වැරදි බලා ගන්න. In this you have to take 2 out. It will come out as square root of 2, 1 over root of 2 dx over square root of x square plus 5 over 2x minus 11 over 2. Now completing the square. Square root of x plus 5 over 4 squared, that's minus 25 over 4 minus 11 over 2, 22. What would be minus 47 over 4? Looks like. Yeah. So now it's ln form 1 over root of 2 ln mod of x plus 5 over 4 plus square root of x plus 5 over 4 squared minus 47 over 4 plus 0. You can check the answer for part 3. And I write the question, part 4. Question is this. Part 4 question is 9 minus 4x minus 2x squared. This you have to take within the square root. You can take 2 out, but not minus 2. We first take 2 out. 2 out because function of x square is 2. So then come out as root of 2. So dx over square root of 9 minus 2x minus x square. Now minus 1 we will take within the square root. So it is 9 minus, I will take x minus 1 out, x square minus 2x. So it's 1 over root 2 dx, integral of dx, 9 minus, within brackets, x minus 1 squared minus 1. So ultimately it is 1 over root of 2 integral dx over square root of square root of 10 minus, yes, you can see it, x minus 1 squared. Yeah. Now it is the sign inverse form. Equals 1 over root 2 is there. This is sign inverse x minus 1 over square root of 10 plus c. Right. ඔය methods දෙක අද ඉගෙන ගත්ත methods දෙක දැන් මේක තේරුණා නේද ළමයි? මම හිතන්නේ එච්චර අමාරු දේවල් නෙමෙයි මේ. ඉගෙන ගත්තන් පස්සේ කරන්න පුළුවන්. කවුරු හරි කියලා දුන්නාන් පස්සේ මේ කරගෙන යන එක වැඩක් නෙමෙයි. මොකද ඔයගොල්ලන්ට වැඩි හිතන්න දෙයක් නැහැ. Right? So you can check the answer there. And that's where we stop today because the next topic is a long one. Next day we start integration of rational functions. It's a long topic, right? Other pattern gonna get වැඩක් නැහැ එක. We'll start it next day. For this week homework, your homework is you have the tutorial page, sorry, exercise C of the tutorial. Homework exercise C of the tut. හරි? ඕක කරලා තියන්න ළමයි. අනිත් දවස් අපි පටන් ගන්නවා ටිකක් ලොකු ටොපික් එකක්. Integration of rational functions. මම හිතන්නේ මේ අද කරපු දේවල් නම් පොඩ්ඩක්වත් අමාරු නැහැ ඔයගොල්ලන්ට. ඉදිරියේ දිනේමත් අමාරු නැහැ. හැබැයි මතක තියෙන්න ඕන මුලින් ඉගෙන ගත්ත ඒවා ආයි පාවිච්චි වෙනවා. හරි? Right. So we stop there today. Then we'll meet on Sunday in the morning for applied maths. Till then, good night everybody. Goodbye everybody. Good night. Budu Satmai. හැම දිනකටම අපි ඔතනින් නවත්වමු.